Hi there. In this video I want to take you through the usual calculus for the wellness questionnaires and the new method I'm working on at the moment, which I think it's more sensitive to a negative states and can sum up the different categories much better. What we usually do in a wellness questionnaires, we collect scores every day, so we need to do it, as much as possible or as frequent as possible. We rate certain categories. In this case, it's sleep, soreness, energy, and mood. In all of these, more is better. So if that's not the case, you need to correct for that or normalize the score. So we rate basically sleep, soreness, energy, and mood, and we tend to usually using a Likert scale from usually from 1 to 5 or 1 to 10. And then usually sum all this up and we get a total wellness score. Over time, you will see that certain players are low raters. So someone usually, it's like a pessimist optimist. So some of them will rate usually lower, let's say 6 over time, and some will usually rate 8. Even in the same scenario or feeling same tiredness objectively. Also, some players tend to swing a lot, so I call them highly variable and low variable. So one day someone with low variety guys could rate 6, 7, 5, 6, and high variable guy will tend to swing more. Again, this is going to be around 6, the average. 6 is the average, and let's say we have a high variable guy that also has a 6 on the average, but he tends to swing about it. So it might be 4 and 8, maybe again 4 and 8. So he tends to go up, rate up and down a lot, and this guy will tend to stick to a certain number. I guess the anchoring procedures are a must because of this issue. So make sure to players know what's very high or very low. I tend to remove the categories in every metric. So sleep it's more like from 1 very bad to 10 very good without the word normal. So I don't use the normal. I have a situation with a player. He asked me, normal. I wanted to ask him his mood. He was a very optimist guy, so he tend to, on his normal, he tends to be very optimistic or in a very positive mood. So he said, like, what should I rate? And then I decided I'm just gonna kick out this category. So anyway, the simplest method is to sum up all these categories, just basic calculus. Then, if this is the last score, this one, feel bad for my drawing. So if that's the last day, we take the sum of these categories for this day and compare it to a baseline or a rolling average. So rolling average could be 7 days, which I think it's a short duration, but and something that's longer, like 28 days or more, could be more insightful. So we compare this number to the rolling average, to these 7, and from this rolling, it's like a rolling window. We take the rolling mean. So what's his usual rating during that period? And again, this could be a baseline. This could be somewhere back in the history. So maybe in a preseason. So what's his usual rating and how variable is his usual rating? Then we calculate the Z-score. So it's basically 28 minus rolling mean, so that's 29, 29, 14, divided by a standard deviation or standard variability, so 445, and we get this number. So he's 2.6 standard deviations, 0.26 standard deviations below his average. We can set certain thresholds based on this number. So it's based on a norm. So if this is mean, I'll call it mean, and this is one standard deviation. I think 60, if I'm correct, 64. 64% of data comes into this range from -1 to +1. And again, there's no right way to do this. So you can, and doesn't necessarily reflects that these numbers are normally distributed, but we can take one as a first warning and +2 as red. So this could be, green, this could be yellow and red, or along those lines. So that's a first method, basically just summing up these categories, individual categories, getting one number and then analyzing this number across and getting how much he differs. This is tricky because I can rate poorly on sleep, let's say very, very bad, but my soreness, and if you get 10 here instead of 8, we're going to have the same sum, so that's 28. And what this means practically is that this method is not catching up this change of so this drastical drop. So if you have a drop here and rise on another category, that's not going to be caught by using a simple sum. So the other method that could be used is this one. So instead of summing wellness, so you can you can still sum them, but you can disregard this. What we do is we calculate rolling averages per every category. So as similar to as we did to a total wellness score, we calculate the z-score per category. So in this case, this number, as we said, 4 minus rolling mean, which is 6.43, divided by the rolling standard deviation, and that's 2.51, and we get z-score of minus 0.97. And again, we do it for every category, and what we can do is to sum these z-scores or average them to get the wellness. Again, similar problem with the above method is that we cannot catch the minus. So if you have something that swings very bad for a category and something that might swing up, they tend to negate each other, and we don't catch that stuff. So instead of just summing these categories, we sum the negative wellness. So we sum the numbers that are below 0, and we sum up the numbers that are above 0. So then we can see what's happening in a negative way and what's happening in a positive way. This is something I've been working on at the moment, so I cannot tell much, not because I don't want to, but because I don't have any information, and I need to try to use this version on a simulated data and some historical data I have, and then on the real data. So I guess this is more promising than just summing up the wellness scores. Regarding the thresholds, because we are summing up, we can't use one standard deviation and two standard deviations. I guess we need to multiply this by number of categories to get real bad sign. So I guess it should be over -4 and over -8. Again, we need to watch for the trend, but if you're setting up the alarms in your athlete management software like Smartabase, we need to experiment with different thresholds. That's all, folks. Try to implement this with your own monitoring, and I guess it gives you a couple of ideas. Till next time.